Alright, so let's go through this kinematics problem where the ball is being thrown up. So imagine we have a girl, right, throwing a ball up. So what should the velocity time graph looks like for the so-called the ball, right? Okay, so first thing first, if we plot a velocity time graph right here, you will notice that my graph is a downward sloping graph. So for example, you will see that for the first 3 seconds, my graph is in the positive region of the graph. Then after that, for the last 3 seconds is in the negative region. So what is going on? So there are 3 points to this graph that is the most important. The very first part will be when you just throw the ball. So when you throw the ball at 0 second, the velocity is 30 meter per second. So this will be the so-called the pictorial sketch. Okay, so first thing, if you look at the ball, right, why do you need to throw it at 30 meter per second? Because you need to give the ball some velocity to rise up. Then after that, at 1 second after it's being released from the girl's hand, right, you'll notice that my velocity is 20 meter per second, and 2 second my velocity is 10, and 3 second my velocity is 0 meter per second. Why do the velocity decrease? Because don't forget, on Earth there is something called the gravity. But normally we don't call it gravity, we call it the acceleration of free fall. So the acceleration is actually negative 10 meter per second square. So it's actually pulling you down, so it's slowing you down. So at 3 seconds, you are actually at the maximum point already. So this is max point. So at maximum point, you actually has a velocity of 0 meter per second. But just take note, for this maximum point, although the velocity is 0 meter per second, but the acceleration, okay, I just denote the magnitude of the acceleration. So the magnitude of the acceleration should be 10 meter per second square. Although you're not moving, but doesn't mean you do not have acceleration. Alright, okay, so this is the third second. Okay, after that, you move down. When you move down at maybe 4 seconds, right, you notice that my velocity is negative 10 meter per second. So what is negative 10 meter per second? So this will be the direction. So negative just means you're moving down. Positive just means you're moving up. So this is negative 10 meter per second. After that, you slowly increase. You are accelerating. Because the acceleration of free fall and velocity is in the same direction. So you are moving faster and faster. So as seen from the graph, right, at 5 seconds is negative 20 meter per second. And last but not least, at 6 seconds, you are actually negative 30 meter per second. So you are actually increasing in your velocity. So the negative is just the direction. So for the positive region, you are moving upward. For the negative region, you are just moving downward. Right, so that is how we interpret this motion graph. So let me just bring attention to page 42 of the notes, right? Okay, so for this, how do I sketch the speed time graph of this motion? So for velocity, we know it's a vector. Then for speed, we know it's a scalar. So for scalar, there shouldn't be any negative region of the graph. So everything must be in the positive region. So the very first part is, same thing, I will start from 30 meter per second, right? So I will take 3 seconds to rise to the so-called the maximum point. Then after that, you will fall. So I'll take another 3 seconds to fall back to the girl's head. So that is how we sketch a speed time graph of a ball being thrown upward.